So again, what I want to do is welcome you to this presentation. We're here to talk about the 3-minute elevator pitch. And so this is a presentation that we've been giving to the Broadcom Foundation students for many years. And the key element is how to convey your information in a concise and precise way. And again, the best quote that we've come up with from Blaise Pascal, the famous mathematician, is, I would have written a shorter letter, but I did not have the time. And so that encapsulates how hard it is actually to boil your ideas down to a very concise pitch and make sure that you convey only the most important information, that you keep your audience's attention, and you actually can convey exactly what you want. So my name's Dave Garrett, and I'm a distinguished engineer at Broadcom Limited. So I've been in engineering for a very long time, and I'm currently designing chips for smartphones, Wi-Fi chips for all the high-end smartphones. So let's take a look at the essence of the 3-minute elevator pitch. And the time duration can change. You can have an 8-minute pitch, a 3-minute pitch. The basic premise of the elevator pitch is you walk into an elevator and there's somebody important in there, the CEO, your department chair, the dean of the engineering school, and you only have the elevator ride to pitch the ideas. And so if you are faced with this scenario, what do? How do you take all the information that you want to convey to them and get that across in 3 minutes and make sure that you hit the highlights, to make sure it's memorable, and to make sure that you don't leave the elevator saying, I wish I had said this, or I should have represented this better. So the main question is, this comes up, should you do this on the fly? Should you make it up as you go along, or should you plan ahead? And I think every single one of you know the answer. And the idea is, if you can think about this well in advance, if you think about your topic in research, if you plan ahead, if you practice and you boil this down, this is going to give you the opportunity to speak very concisely and be ready to go with the message that you want to convey. So I was recently, I was watching a documentary about Richard Branson, and he has his island in the Caribbean. He was joking about putting an elevator in just to make people pitch. He was going to specially install an elevator so that when you rode with the elevator, that's all the time you had to pitch to him, and then you had to move on and enjoy the Caribbean, I think it was. But again, this is how far this is propagated into the culture. This is a very key element of things that you're going to need to do. So now let's boil it down. These are, again, the 4 key points that you want to take a look at. So what you really need to have is the concise description of your project and the contribution. This is it. You have to think it down and boil it down to the essence of your project. This is not a 10-minute discourse on all the different pieces of that, but it's like the thesis, the overarching theme of your project and your contribution, and you have to boil it down so that it's memorable and someone can remember that one sentence. The second piece that you want to make sure that you get across is you have to find the novelty and the uniqueness that you want to convey. So again, there's the overall project, but what you really want is what we call the hook, which is what amazes somebody, or someone goes, aha, those people really know what they're doing. This is a novel solution, or this is really what they, the most important thing that they fixed and that's not obvious. And so this is usually the thing that makes your presentation memorable. Someone will remember this piece, the hook. And again, you have to, look at your project, see if you can figure out what that hook is, and that's really what's going to come across and make the presentation memorable. Of course, we're in engineering, so there's quantitative results that validate your approach. So if you have the data to back it up, you can present that. Hey, this is why you should trust me. I have validated this. I've run experiments. These are lab results. These are the reasons that my presentation you should trust. And again, you cannot knock them over with pages and pages and pages of graphs and complicated things. You got to figure out what's the most important thing to prove that your assertions are correct and present that. And so that also leaves people with the impression that you know what you're doing. And hopefully you do. Now, the last element of this is also important, and what you're trying to convey is how does this affect the future. So it's not just what you're solving today, but what you want to show people is how the gains of this project can multiply over time. Because I've solved this particular problem, these people will be able to do something else in the future. They'll build on this. This is going to lead to, solving world hunger. It's important to show people not only what the project is today and how good you've done it and what's unique about it. All these three things are important, but what you want to leave people thinking is, what is this going to do for the community, for the engineering, community, and how it's going to affect everybody in the future, and how people are going to build on your results. That you can say that, I've stood on the shoulders of giants to go forward. That's what this is about, is making sure that your results fit into, the literature and fit into all the work that's being done, and to make sure that that's building on what people need to do in the future. Now, let's take a look at the important considerations. So we talked about the 4 elements that you need to convey in your talk, but there's still some very important things that you have to consider when framing those discussions. So the very first consideration that we think is very, very important is you have to go with the frame of reference of your audience. So think about this. If you're presenting to your technical peers in your lab, you're going to assume many of the fundamentals, the acronyms are going to flow like water. You're going to know the baseline is there, and you're just trying to establish the important things on top of your peers, already assumed knowledge if they're in the same lab and already in the same field. Now, if you're presenting to a wider audience, let's say, more like this workshop, not everyone is going to be working deeply in the same field. So you may need to step back and establish the baseline and or simplify the results. So it's very important, again, to consider your audience. And I've seen it many times where you're going to leave the audience behind and they're going to be lost either in too much detail, too highly technical, and you just got to take a step back and say, well, what would they need to know? What's the most important thing that they need to think about? The other consideration is, again, always ask yourself why. Why did the people come to hear me? So, there's a reason that people are going to come listen to your presentation. They're going to want to learn something. And you have to ask yourself, why am I presenting? And that will tell you what's important, the important parts of things that you need to say. And then also, what is my goal in sharing these ideas? So I'm, looking to get funding for research, or I'm looking to impress this particular group of people to, for jobs, things like that. You have to think about why and what is your goal in sharing these ideas, and that will help you to convey which ones you should exaggerate, which ones you should minimize, and how you fit this into a very compact presentation. So the other in consideration we talk about is, at some point we need you to put in an extremely compelling diagram. So the hard part is, words alone are very hard to convey all these, what you've done in your research. So what we want to do is take a visual, and it's got to be a wow kind of picture. So what you take is, you take your system and you have a very complicated structure. You're going to present that and show a very good diagram that people are going to, look at that. They'll say, wow, and it's going to establish your technical credibility. Now, the trick behind this type of these diagrams is you can't spend too much time. If there's 100 pieces of the diagram, it goes to show someone how complicated that things that you're worked on, but you can't get lost in the weeds and spend too much time explaining each box of the picture. So the key is, show how hard it is what you're doing with these, like a compelling diagram, but then go back to the previous slide and think about, well, let's summarize only the most important things, or let's point out the highlights of this. And so spend the time, effectively still following the rules of trying to finish a talk in 3 minutes. Now, again, we're talking about soft topics. There's a last little bit. How do you make a lasting impression? And so these are even as important as framing the technical discussions and your ideas and summarizing them. That's important. But the other part of how to make a lasting impression are the non-tangibles. Smile. You got to say hello. You have to introduce yourself. We talk about stand up straight, be confident. You don't rush a presentation. And you think about as fast as you think you're talking, it sounds faster to the audience. So you need to exaggerate that and slow down in terms of your speech because it's going to sound more like a presentation. There's some key points in the audience. You also need some things to sink in at some point. The most important thing about your project, when you announce that, you need to stop, pause, and let the whole audience, think on that. Let that sink into the back of their brain. And so pausing as opposed to running through the presentation from beginning to end is a very important part. You can't pause too often, but let's pick the key places that you want to insert that. The other thing we do is you got to divide your talk into a beginning, middle, and the end. And the funny thing is, this is going to sound redundant, but what you're going to do is you're going to tell the audience what you're going to talk about. Then you're pretty much going to tell them everything you want to talk in your presentation. And at the end, you're going to recap. You're going to close with the summary sentence. I'm glad that I allowed you to share my project about X. So you're going to tell them what you're going to tell them. You're going to tell them about it. And then you're going to tell them what you told them. So it sounds interesting, redundant, but what it leaves the audience with is it first off frames how they're going to listen to the following presentation. You're going to dive into the material that you want to present. And then your closing remarks are going to wrap it up, and so you're going to have something that's memorable and a key piece of information. Again, smile, say thank you. You got to make sure that you come across as a good presenter, and people like to listen to what you're saying. Good. So that's the elements of the pitch. So unfortunately, I've told you how to make a 3-minute pitch, and I think I've taken more than 3 minutes. So unfortunately, I don't know if I'm violating my rules. But what I want to do now is we have some slides, some 3-minute elevator pitches from previous Broadcom Foundation student research presentations. So I have 3 of them that I want to go through and just talk through some of the things that are interesting from those presentations. So this is Shir Feibish from Tel Aviv, and this was in our Broadcom Foundation University Research Competition in 2014. And she won 2nd place overall in the competition that we ran that year. And again, what you'll see is it's a pretty good slide, a very compact slide. What she was looking at is the 0-day signature extraction for high volume attacks. So this is related to security, very complicated analysis of the traffic to see if they can find denial of service attacks. So again, the slide has boiled it down to a very simple block diagram here. So you can see the diagram, which is very good at conveying exactly what she wanted to talk about. And so you have, again, the peacetime samples, the attack samples. What she's done is taken a very complicated program and boiled it down that I can remember why this is why this works and what they were able to accomplish. And so, again, so she framed the problem. There's millions and millions of requests on the denial of service attack per 10 minutes. So you frame that as very important. She has a very compact solution. Our solution is to automatically extract the attack signatures. And then she pushes the benefits of this in very clear terms. This is how we're going to make it accurate, minimum number of signatures. And then at the end, what you're going to take a look at is this is how it's going to help in the future. This is going to work with real attacks from top security companies, and you're left with the impression that this research actually will make a difference in the denial of service, the ability to attack those, and to have her analysis make a difference in security for real companies. So again, this is a excellent presentation. She conveyed exactly what she needed to do in the 3 minutes. This is another one from 2014, Hans Mavart from KU Leuven, and he was a 3rd place winner. And so this is the one where he's got this is a hardcore circuits project. And so he was working on a monolithic low power supply, and he was looking at actually taking 400 volts down to CMOS levels. And so again, he's got very complicated diagrams. He's got his the amplifiers, the circuits that he's got, and then he's got the the pictures of the layout, and so it gives you the scale of what he was able to accomplish. And then he's got some of the the structures on the right-hand side, like the high voltage terminal. The key thing that he was trying to solve is how to stack these transistors to absorb 400 volts in. And so he has a diagram that at once conveys very complex circuits. It looks at the scale that he's actually taped out, silicon. He's got real working parts, but on the other hand, he's got some block diagrams that he can explain to. So this one is, again, he's got some results. He's got this, the boil it down to the approach. He's got all kinds of circuit techniques, but again, his approach is confined high voltages with custom-built passive component structures. That is the amazing part of this presentation. So that's why he's added that nice little bullet point. And again, framing the results, he's got a very compact table which represents the state of the art, his work, and how much more impressive it is. And then, this is a very good way to represent his project. So let's take a look at the last slide that I want to talk about, and this is Yang-Yo Kim from UCLA. This was from 2013, first place. So again, take a look at the diagram. This is a very compelling diagram, and it conveys most of the things that he wanted to do in a very simple way. So what they were looking to do is, he's got a nice bullet point that says, let's set up the problem. We need a low-cost, low-power, high-speed data link for multimedia processing. And their solution was to go with an industrial plastic pipe. So the diagram shows the pipe at the top. You get a picture of exactly what he's talking about running it through. Then you see that you've got the millimeter wave transmitter on the left and the millimeter wave receiver on the right, and it's propagating through this medium. And then he's also got a very neat diagram which has the wave propagation properties. So the simulated wave propagation is a very complicated simulation that's looking at the modes of the plastic fiber and represents that in a way you say, aha, okay, I see what they're doing. A lot of work to analyze this, even though it looks like a simple project. And again, the transmitter and the receiver, I'm sure, are very complicated circuits. They're not easy to design, but he didn't spend the time to say, well, look, these are the details inside there. The most important thing is analyzing the wave propagation. But the fact is, still, they have the transmitters and receivers there, so that's an attempt or a good job at abstracting the things that you want to not spend time on, even though there's complicated underneath. So again, they have a very compact table which he could speak to and represent why, how well this technology is going to work compared to the other technologies. So again, this was again, we've looked at 3 good slides. Each of the presenters spent a lot of time working on these single-page slides. And more importantly, when they stood up, they followed most of the tenets of these 3-minute pitch, and they were able to give very effective presentations. So they were all winners within all of these competitions that we ran, and it's a combination of doing good research, spending the time to do really good slides, and then also the active presentation. They were rated on their presentation. They did a good job of slowing down, smiling, making sure they cover the key points. And so, that wraps that up. So again, at this point, I've concluded my talk. What we'll do is we'll open it up for questions. I'm happy to answer any questions you have now live on the phone. Absolutely, send me an email later if you have any thoughts. A lot of times, what you should do is you need to get peer feedback before you do talks like these. So the most important thing is to do a talk, but also to share that with somebody. Do practice talks. We try to do, for big presentations, we try and do practice talks, and you have to be ready to accept the constructive criticism. So sometimes it's not fun to hear something that you're not doing well, but it's very important to get that feedback. So when you're working on your presentations for the workshop, make sure that you do trial presentations. Make sure you experience the presentation as you're going to do it, because it's going to be very important. You don't want to discover something live in front of the audience. You want to make sure you know ahead of time how exactly it's going to go, and you've experienced all the issues that you want to do for the presentation, and then you also see what works and what doesn't work, and you adapt and overcome. So again, thanks for your time. Let's open it up for questions if you have any. Otherwise, we can wrap it up. Go ahead.
This is Paula Golden. I was curious if you could just say one or two more words about these guys are going to have to operate very quickly as a team to do this. Do you have any thoughts about the division of labor? Once they get to know each other, they obviously are going to come into their teams as strangers, but after 2 intense days together, they're going to be in a very different position with each other. Do you have some thoughts on team building that may go into helping them execute your ideas and good advice on a presentation?
Yeah, I mean, the interesting thing with team presentations is sometimes it can be discontinuous. So that's a it's an interesting challenge, is how to do an effective presentation that's split between team members. The one thing I could think of is, as a team, you need to sit down and everybody work through the whole presentation and really divide up, do the, in this case, like say it's an 8-minute presentation. So work on the 8-minute presentation together and make the whole thing seamless. So what's the worst thing is when you have multiple presenters, if the multiple presenters say the same things. So I have a first 3-minute part, and I'm actually going to say something. The second 3-minute part rehashes essentially the other one because you haven't coordinated the presentation. So the key thing is all sit down as a group. Everybody sit down and agree exactly how the presentation should flow. And then only when you've got that structure in place, then divvy up who you want to present on for each of the sections. And, try and divvy it up equally. That's the important part. And try and make sure that everyone's comfortable with the pieces that they're going to talk about. But in the end, you can't be upset that I didn't get to present the best results because I'm doing the introduction side. You got to be comfortable in that the whole presentation comes together as one big piece, and the elements will add up, and you guys will be stronger as a team is if you can fit in and have a presentation as if one person was doing it, and it's a nice continuity as if it was a single presentation. But each of you gets to shine in the strong points and split that up.
We have a comment or a question, actually. Well, the three of us were of the opinion that the slides that you gave as examples actually had too much text. And we were thinking for a 3-minute presentation, every sentence you speak matters, and you really have to keep your audience attention all the time. So one of the objectives of your slides is just not to distract at all. So we were thinking there was just too much text. What do you think of that?
Yeah, okay, that's a good point. There is definitely a reliance on text when people do presentations, and so that's a very valid point. I'll tell you the style that some people will do is there's too much text on their slide because they want to make sure when they stand up they can remember what to talk about. So that's really what text is in your slides, is their prompts that you can remember what you're supposed to speak on that side. So the good news, for you guys, like that's your style is, I think there should be less text on there. And if you spend the time ahead of time to know exactly what you're going to say, and you don't need all the text to prompt, then yeah, you can boil it down. If you're less comfortable speaking on the fly, that's why some people put a little bit more text to help them as a cue to remember what to talk about on the slides. Again, it all comes down to how many times you practice ahead of time, and if you want to try and do it on the fly or have less of a pre-recorded speech and have some cues available. But again, I think that's great. The less text that you can put, I think that's very important. and it just comes with work ahead of time to get ready for it. But that's good. I like that comment.
I also have a question then, because you were saying before that you need to address your audience based on their knowledge. But my general question is that if you're in a very interdisciplinary field, a lot of times I feel like you don't really know how much do your audience know. So how do you assess that? Like, how do you try to figure it out during your presentation or before your presentation?
Right. Well, okay, so the example from these slides, these were given at a Broadcom event, and it was, the entire upper level engineering teams were in attendance of these talks. And so you could already assume that the people that listening were actually in semiconductors and have spent 10 years at plus in their careers, and so they're pretty well, ready for semiconductors, communication protocols, all the things that Broadcom does, that you can assume that they're up to speed on that. But if you're giving the same talk to a high school, okay, well, they don't have an engineering degree, so maybe I've got to try and find something common ground. So think about what a person in high school would know, like what classes they have taken, what baseline they're from, and you got to frame it in something that relates to something they know. So if a high school student's already taken high school physics, there's some tenets that you can lean on. You can say, oh, it's like this. It's like the current equations you've looked at. But you won't be able to say, well, I have, CMOS transistors and the P channel has been doped to a certain level, like that's too high. So the trick is going into the presentation is thinking about the audience and then finding the common ground or something that you can make an analogy to that they would relate to. And again, if you went to a grade school and if you're trying to get kids excited about engineering, again, it's way, way, way down even further. And then, the denial of service attack, if the Shear's presentation, you would just say, hey, people, are going to bombard me with thousands and thousands of questions, and I'm just trying to figure out which question is actually real. So you have to scale up or down based on that. And then the last part of that is there's an element of pivoting in the presentation itself. And you'll get this sometimes when you stand up in front of people. You can get dumb looks. I've definitely had presentations that aren't working, and you look out at the audience and there's blank faces, and I've even had people nod off, and sometimes you have to kind of read that, and this is a much harder task, is read the room and figure out, okay, well, I've gone too long, let's move on, or, oh, they're in rapt attention, they're very interested in what I'm saying, maybe we could spend a little bit of time diving down. So to summary, know the audience, look for the way that you could relate to them, and then on top of that, be ready to adapt as you're giving a talk live.
Thanks.
Yep. Well, good. Let me know if you have any other questions. Otherwise, when I think we can close this out. Good luck. These workshops are definitely a lot of fun. It's going to be an intense couple days. I think you guys are going to have a great time. There's always a great part of getting together with people from different disciplines and actually, people from around the world. You find out the world is not all that big after all.